Hello there, Mr. Sutton here with the IM314 Part 2 homework solutions on systems word problems. For this problem, we have the Sluggers going out to pizza after a game. Woohoo! 7 large pizzas plus 2 mediums together have 100 slices, apparently, and 5 larges and 6 mediums will have 108 slices. We want to know the number of slices in each size, and don't even ask how we came up with this information. Maybe they just hungrily watched other people and counted the number of slices. I don't know. Who cares? So let's define our variables. We're trying to figure out how many slices are in each size. So let's define a variable for the number of slices in a medium pizza. We'll call that M. And then we'll say L is the number of slices in a large pizza. And you can use uppercase if you want. This lowercase l kind of looks like a 1, but we're just going to roll with it. So we're going to set up some equations based off of these. If 7 larges and 2 mediums gives you 100 slices, well, that means that 7L, so 7 times the number of slices in a large pizza, 7L, plus the number of slices in those 2 medium pizzas, that's 2M, all of that has to add up to 100. So that's one equation we can use. Now for the other equation, they said 5 larges and 6 mediums gave you 108 slices. So we've got 5 times L plus 6 times M equals 108. And now we have a system of equations that we can solve. Substitution or elimination, whichever you want. I would say elimination is going to work out better. Substitution, when you isolate a variable anywhere really, you're going to end up working with fractions or decimals. So to avoid that, we can do a quick elimination. Now, if we add these together the way they are, nothing's going to cancel. But I could very easily turn this 2m right here into a negative 6m, which would cancel out this 6m. So let me multiply this first equation by negative 3. That'll give me negative 21L minus 6m equals negative 600, or negative 300 rather. Adding these together now, those 6m's are gone. 5 minus 21, that's negative 16L on the left side. On the right side, this is going to be negative 192. And you might want to use a calculator to divide both sides by negative 16, or you could reason it out a little bit. 160 divided by 16 would be 10, and this is 32 greater than that, so it's going to be 2 greater for the answer. So calculator or not, you end up with 12 for the value of L, so that's 12 slices in a large pizza, which seems reasonable in real-life terms. Now we have to figure out the number of slices in a medium pizza, so let's plug 12 in for L in this other equation over here. Either of these equations is fine, but you got to pick one. So 7 times 12 plus 2m equals 100 then. 7 times 12 is 84. Subtract that from 100, we've got 16. So that's saying that 2 medium pizzas have 16 slices altogether. So individually, each of them, if you divide by 2, must have 8 slices. For this problem, we're told the price of a sweater is 5 less than twice the price of a pair of pants. If 4 sweaters and 3 pants cost $200, ooh, that's an expensive trip, we want the price of each pair of pants and each sweater. All right, so let's define some variables. We want the price of pants and the price of a sweater. I'll let P be the price of one pair of pants, and we'll say S is the price of one sweater. So using the first sentence that they gave us, the first piece of information, they said the price of a sweater, which we said was S, is, so equals, 5 less than twice the price of pants. So twice the price of pants, that would be 2 times P, and we want 5 less than that, so minus 5. So that's our first equation. Now we need another equation because this by itself is not enough to solve for S or P. So for the next one, we'll use our next sentence. They said that 4 sweaters and 3 pants cost $200. So the value of 4 sweaters, that's going to be 4 times S, plus the value of 3 pants, so that's 3 times P. That should add up equal 200. So there's our second equation. Now we just have to solve this system using substitution or elimination. And either one will work, but because we already have S isolated in this first equation, I'm thinking substitution is going to be a faster way to do this one. So I'm going to substitute 2P minus 5 for the S over in this second equation. So I can write 4 parentheses 2p minus 5 plus the 3p that's already there equals 200. Distributing, we've got 8p minus 20 plus 3p equals 200. So that's going to be 11p if I add those together. And let me just add the 20 over to the other side to get 220. Dividing both sides by 11, we get p equals $20. All right, so that's the price of a pair of pants. Let's find the price of a sweater now. So now that we know p, we can plug it back into this other equation right here. So I have the price of a sweater is going to be 2 times 20, 2 times the price of a pair of pants, minus 5. So that's 40 minus 5, which is $35 for the price of a sweater. For this problem, we have Annie going shopping and buying 2 phones and 3 chargers for $610, and Jacob got 3 phones and 4 chargers for $885. We want to know how much a phone costs and how much a charger costs. So let's define variables for each of those things we're looking for. The cost of a phone, we will let P represent that, and then the cost of a charger will be C. Now we're going to go ahead and set up 2 different equations based on each of these 2 shoppers' experiences. So we have Annie getting 2 phones and 3 chargers for $610. We can write that 2 times the price of a phone, so the value of all the phones, we'll write 2p, plus the value of the 3 chargers, that's 3 times the price per charger of C. That should all add up to the $610 that Annie paid at the store. And we'll do the same thing for Jacob's shopping trip here. We said 3 phones, so 3p, and 4 chargers, so plus 4c, had a value of $885, so equals $885. And at this point, we have to use substitution or elimination to solve this system of equations. So I would say elimination is probably going to work better here. Substitution, you're probably going to get some decimals or fractions involved, which makes things a little bit tougher. So for elimination, we have to pick a variable that we want to get rid of here. And this is one of those situations, half a dozen of one, 6 of the other. It doesn't really matter. They're both going to be about the same amount of time. I'm just going to get rid of the first variable, p. So I see we have a 2p and a 3p. Those are not going to cancel out if I add these together. So I'm going to turn them into a number that they're both multiples into. So 6 is the smallest multiple of 2 and 3. So if I have a 6p and a negative 6p, those would cancel. So let me start by multiplying this equation then by 2. Got to start somewhere. That'll give me 6p plus 8c equals, 2 times 800 is 1600, 2 times 85, that's going to be 170, so that's going to be 1,770, yep. And then we have to multiply this other equation now so that I get a negative 6p. So let me multiply this by negative 3, giving me negative 6p minus 9c, and then this will be negative 1,830. Adding those 2 equations together, those 6p's happily cancel, and 8c minus 9c is just negative c, so that's pretty good. Over here, 1770 minus 1830, that's going to be negative 60. And then dividing both of these by negative 1, we have the price of a charger, C, equals $60. To get the price of a phone, let's go ahead and plug 60 in for C. Over in this equation here, doesn't matter where, but might as well be here. So we've got 2p plus 3 times 60 equals to 610. 3 times 60 is 180. Subtract that from 610 and you've got 430. And then divide that by 2 to get the price of a phone. That's going to be $215. For this problem, we have 6 boxes of oranges and 5 boxes of grapefruits, equaling $183 in value. And then 3 orange boxes and 2 grapefruit boxes adds up to 84. We want the cost of 1 box of each of these fruits. So let's start by defining variables for the things we're solving for. We want to know the cost of 1 box of oranges. I'll let that be represented by O, which is kind of risky because this looks like a 0 if you're not careful. But hey, let's go with it. And then we're going to use G for grapefruits. So G is the price of 1 box of grapefruits. Let's set up 2 equations now. They told us that 6 orange boxes and 5 grapefruit boxes added up to $183. So the value of 6 boxes of oranges, that's 6 times the value of 1 box, so 6 times O, plus the value of the 5 grapefruit boxes, 5 times the price of 1, 5 times G, that should add up to 183. Now for the other equation, same kind of reasoning. We have the value of the oranges, which is going to be 3 times O in this case, plus the value of the grapefruits, so 2 times G, equals 84. And at this point, it's either substitution or elimination. Elimination is definitely going to work better in this case. If you try to isolate something for substitution, you're going to end up using decimals or fractions. So to do elimination, we need to have things cancel when I add the equations together. Nothing's going to cancel right away, but if I were to multiply this equation here by -2, that would give me a -6O, which would very quickly cancel the 6O that I already have in that first equation. So let's go ahead and do that. So we have -6O, and now everything else also gets multiplied by -2. So minus 4G equals -168. Adding those equations together, these 6 O's cancel. 5G plus -4G, this is nice. This is just 1G, which is what we're solving for. One of the things anyway. And that's going to equal, this is going to be 15. So $15 for 1 box of grapefruits. And now to get the orange price, we're going to plug 15 in for G over here. So 3O plus 2 times 15 is 84. 2 times 15 is 30. Subtract 30, we get 54. So 3 boxes of oranges are going to equal $54. So dividing by 3 then, we're going to end up with $18 for 1 box of oranges.